First, hello, we are Jeffrey and Jason, and we research heuristics of the sector problem to advise industry practitioners in operation research. First, introduction. The sector problem, referred to as SCP, is a classical computer science problem where we want to minimize the total cost to cover a set of objects with a family of sets. A few examples of the application of SCP include operations research and data mining. To solve SCP, the optimum solution is found to be NP hard, meaning the total runtime will increase immensely as the sizes increase. Approximate solutions are used instead to solve SCP as they are much faster, so we focus on a deterministic algorithm, Shivato's Gree algorithm. Now we have enough background to set up our project. We implement the naive Gree algorithm, an optimized Gree algorithm written by us, and two exact algorithms which would help solve for the optimal solution. We wrote a random test case generator to study the effects of density on the runtime total cost and approximation ratio of the heuristics. We then carry out our research by running all possible combinations of algorithms and specified test cases. Here are the results of this setup. We observed the exact algorithm runtime being significantly greater than greedy algorithm, and our optimized greedy was usually 10 times faster. We also saw the density of sets influence both the runtime and the total cost. The average approximation ratio was found to be within 1.2 of our test, much less compared to the theoretical upper bound of the approximation ratio of the greedy algorithm. When examining the runtime, we found that naive greedy actually performed better compared to the optimized greedy, which is quite unexpected. Since densities are mostly lowering practices, we expect our optimization to run quickly for even very high matrix sizes. We've proposed multiple implementations for use in various contexts. Lastly, our results suggest that SCP heuristics are generally more viable than theory predicts, especially given that industry practitioners have much better computational resources.